We use them every single day. We step in, press a button, and step out, and we never really give it a second thought. But that simple box, the elevator, is a total marvel of engineering, and it's hiding this one really elegant secret at its core. So let's find out what it is. So, have you ever actually stopped to wonder, what is that secret? What's the simple but super powerful force that's responsible for lifting millions of us hundreds of stories into the air, safely, efficiently, every single day? I'm telling you, the answer, it's going to surprise you. All right, so here's what we're going to cover today. We'll start with that crucial secret, the idea of traction. Then we'll check out the three main types of elevator tech. After that, we'll get into the real-world trade-offs: price, space, and noise. Then, we'll uncover the hidden rules for designing an entire bank of elevators. And finally, we'll see how this all comes together in the biggest challenge of all: skyscrapers. Okay, let's dive right in. Section 1. The secret of traction. Seriously, the entire world of modern elevators, everything, hinges on this one single concept, this one word that makes everything else possible: traction. A lot of people think an elevator is just like a crane, right? That it's just winding up a rope on some big drum. But nope, that's not it at all. A modern traction elevator works by gripping the rope. The motor turns this grooved wheel. It's called the sheave, and it's the friction between that sheave and the ropes that actually moves the car. Honestly, the whole concept is super intuitive when you think about it. It's the exact same idea as a car's tire gripping the road, right? If there's no grip, no traction, that tire just spins and you go nowhere. Well, for an elevator, it's the exact same thing. No grip, no go. Okay, here's an even crazier example. Picture a massive ship, like a freighter, being tied to a dock. A single person can hold that whole giant vessel in place just by wrapping the rope around a post a few times. That's called the capstan principle. Every single wrap multiplies the force of friction, and that's exactly what elevators do to amplify their grip on the ropes. It lets a pretty small motor control a huge, heavy elevator car. Okay, so now that we've got that core principle of grip down, let's see how it's actually used out in the real world. Turns out, architects and engineers have three main flavors of elevator technology to choose from. So the three main options are hydraulic, geared traction, and gearless traction. Hydraulic is the old school simple one. It literally pushes the car up from below with a giant piston, perfect for short, low-rise buildings. Then you've got the two traction types. Geared uses a gearbox, kind of like a car's transmission. And then there's gearless, where the motor is hooked directly to the sheave. That's the one you want for top-tier speed and efficiency. But here's the thing. Choosing between them isn't just about how tall the building is. It's this really fascinating balancing act. You've got cost, the actual physical space the machine takes up, and, of course, the experience for the person riding inside. These are the real-world engineering trade-offs. All right, let's talk money first. So if we say a basic hydraulic system costs, let's call it 100 units to install, a traditional geared traction system is going to run you about 150. That's 50% more. But look at that last bar. A modern gearless, what they call machine room-less, or MRL elevator, is surprisingly competitive. It's only about 15% more than the cheap hydraulic option to get started. And this next part, this is a huge deal for architects. That old-school geared traction system, with its giant motor and its own separate machine room, takes up a ton of space. But that MRL gearless design, the whole machine, it fits right inside the elevator shaft itself. It's by far the most space efficient, which means it gives valuable square footage back to the building. And trust me, architects love that. But what about for you, the person actually riding in the car? Well, it turns out that gearbox in a geared elevator is a massive source of noise and vibration. You can feel it. The gearless systems, though, since they don't have that clunky mechanical link, they offer a dramatically smoother and quieter ride. It's definitely the premium experience. All right, this next part is really cool. We're going to get into a set of unwritten rules that architects and engineers absolutely live by. It's the hidden logic that controls how you experience a lobby. And I promise you, once you see it, you are going to notice it everywhere you go. It all comes down to two simple numbers. The first one is 8. The industry best practice is that you should never, ever have more than 8 elevators working together in a single group, all controlled by one set of call buttons. 8 is the max. And the second magic number is 4. You should never put more than 4 elevator doors in a single straight line. If there are more than 4, you'll almost always see them split up, facing each other. So, what's going on? Why these specific numbers? Well, it's all about simple human factors, things we've all experienced. If you have more than 8 elevators in a group or more than 4 doors in a line, we just can't quickly see which car has arrived. You know that feeling. You hear the ding, look around frantically, and by the time you spot it and run over, the doors are closing. This rule also prevents that awkward traffic jam of people trying to get out while you're trying to get in. It's all about smooth, efficient flow for people. Okay, so if those are the rules, then how in the world do you build a skyscraper? How do you serve hundreds of floors without totally breaking these fundamental rules of efficiency? This is where everything we've talked about really comes together. So let's take the ultimate test case, a megatall building like the Burj Khalifa. How does a place like that solve this puzzle? How do they apply the 8-car, 4-in-a-line rule to a building with over 160 floors and not have complete and utter chaos in the lobby? Get ready for this number. The Burj Khalifa has 57 elevators. 57. So obviously they're not all lined up in one giant group in the main lobby. So what's the secret? What's the strategy? It's actually pure genius. They don't break the rules. They build a system of systems. First, they split the building into vertical zones, low, mid, high. Then you have express elevators that act like a subway, shooting you straight up to what's called a sky lobby. From there, you transfer to a smaller, local bank of elevators, one that follows our 8-4 rule, that just serves that specific zone. And to top it all off, they even use double-decker cars, 2 cars stacked in one shaft, to almost double their capacity. And the powerhouse behind this entire, incredibly complex ballet of human movement? Well, it all comes right back to the very first thing we talked about. Every single one of those main elevators in the Burj Khalifa is a high-speed, super efficient, gearless traction elevator. It's the ultimate application of that simple, powerful principle of grip. I mean, it's just an incredible story when you stop and think about it. From a simple principle of grip, we engineered a system that literally allows entire cities to exist vertically, up in the clouds. It really makes you wonder, doesn't it? We took this machine that we all take for granted and pushed it to its absolute limits, and in doing so, we completely redefined architecture itself. So I'll leave you with this. What other piece of everyday technology is out there, just waiting for its reinvention?